question 1, we're given several differential equations and we're asked to classify them according to their order, whether they're linear or non-linear. And in the case where the equation is linear, we're asked to determine if it has constant or variable coefficients and whether it's homogeneous or inhomogeneous. So here I've just taken 3 examples from the plethora of examples you were given. So in part A, we're asked to classify this equation here. Y double prime of x plus x squared sine of x times y of x is equal to x cubed. So first, the order of the equation. Recall that the order of an ODE, it's the order of the highest order derivative appearing in the equation. So specifically, this equation has a second order derivative. So the order of the equation would be 2. Now, is the equation linear or non-linear? So recall that an ODE is linear if all of its terms are linear in y. So this first term here, that's linear in y. We have a second order derivative, so it's linear in y. So the second term, again, linear in y. We only have a y of x, it's linear in y. And of course, this third term, there's no y. So this equation would be linear because all of its terms are linear in y. Now, because it's linear, we have 2 additional parts to answer. First, we have to classify it as if it has constant or variable coefficients. So the coefficient of y double prime, again, that's just 1, constant. Now the coefficient of y of x here, that's x squared sine of x. So that's a variable coefficient. As you change x, the coefficient of y will change. So this equation has variable coefficients. Specifically, y has variable coefficients. And that's because of the x squared sine of x term. Next, is it homogeneous or inhomogeneous? So an ODE is homogeneous if each of its terms is proportional to y. So the first term, that's proportional to y. It has a y double prime. Second term, it's proportional to y. It has a y. Now this third term here, there's no y in this third term. So hence the third term is not proportional to y, and hence the equation is inhomogeneous because not each of its terms are proportional to y. So this equation would be inhomogeneous. And that's because of the x cubed term. This third term here is not proportional to y. So in part B, we're given the exact same equation with one small difference. Instead of y in the second term, we have y squared. So again, the order of this equation would be the same, 2, the order of the highest order derivative. Now, is the equation linear or non-linear? Well, this first term here, it's linear in y. The second term is non-linear in y because we have a y squared. So because this second term is non-linear in y, this equation would be non-linear. And that's because of the x squared sine of x y squared term. We have a non-linear term in y, hence the ODE is non-linear. This third example, we're given a different equation. We're given y prime of x plus e to the x y of x is equal to 0. The order of this equation would be 1. Is the equation linear or non-linear? Well, the first term here, that's linear in y. The second term, again, linear in y. And the third term, well, there's no y dependence. So this equation would be linear. Now, because it's linear, we have to determine first if it has constant or variable coefficients. Well, in this case, the coefficient of y prime, that's just 1 constant. But the coefficient of y is e to the x. It's a variable coefficient. It varies with x. So in this case, the ODE has variable coefficients. And that's because of the e to the x y term. And second, we have to determine if the equation is homogeneous or inhomogeneous. Well, the first term here, that's proportional to y. The second term, proportional to y. This third term here, there's no y dependence. So the equation again would be homogeneous.